how do you deploy software? Well, it's easy, right? You log onto the machine, you bring the service down, you FTP in a new binary, and you bring it all back up. Okay, maybe that would work if there were just one developer working on one machine. But what happens when you're dealing with a cluster of machines? You're probably going to automate it away these days. You're probably going to use something like Kubernetes, maybe Nomad, maybe NixOps, depending on what spiciness level you're at. But what happens when you get beyond the scale of those kinds of tools? When you're managing a whole host of services, some of which are at different versions, across not just one cluster, but hundreds of them. That's when you get into a whole new level of problems. And in our continuing informal series of things that I would like to understand, but I want someone else to worry about, we're joined today by Rashmi Prabhu, who leads a team at Confluent dealing with exactly these kinds of super scale deployment problems. The kinds of problems that maybe a decade ago only Google and AWS were thinking about, but now they're becoming more and more part of our life in an online cloud providing world. Before we get into the gory details of that, I'll remind you that if you don't want to deal with managing your own Apache Kafka clusters, then you should check out Confluent.cloud, where you can easily spin up a development instance or a cluster fit for a major enterprise. Sign up with the code podcast100 and we'll give you $100 of extra free credit. And once you've stopped worrying about managing your own Kafka, check out developer.confluent.io, which will teach you everything we know about how to use Kafka and how to get the best from it. And with that, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. My guest today is Rashmi Prabhu. Rashmi, welcome to the show.
Hey, thanks. Nice to be here.
Yeah, good to have you here. So you've got a background in interesting places like Yahoo. And I know you worked at Box, which I don't know much about. I'm sure you'll fill me in offline.
Mm-hmm.
But right now, you're head of fleet management for Confluent, which I confess I don't know what fleet management really is. So that's what we're going to talk about. How long have you been at Confluent?
I've been in Confluent close to 3 years now.
3 years. Okay, yep. So you really know your way around.
Looks like it.
Cool. So, for just at a high level, tell us what fleet management is for those that don't know.
Yeah, sure. Yeah. So fleet management, when I first started trying to research this whole topic, there was not a whole lot on the internet. It was like, what is fleet management? It popped up cars and it popped up, something about transport and all of that. And I wasn't quite sure whether it was just the terminology or, why that wasn't really coming up. And I think for us, fleet management basically means how we run our Confluent software in the cloud. And it's about being able to run all the different applications, services, infrastructural components, the products themselves, like Kafka, ksqlDB, Connect, Schema Registry, all of them at scale on the cloud for our customers in a very safe and reliable manner. So that is our primary mission at Confluent.
So is the analogy there then you're treating these different software products as like a fleet of cars that you're managing out in the field?
Yeah, it's kind of, that's how I would draw parallels. Yeah.
Okay. So that kind of scale, you're going to know all the horrific things that you need to deal with out in that world. Let's start from my point of ignorance and you can teach me what I'm missing here. So you've got these different pieces of software, you've got lots of machines. So I would think you just sign off a release and you roll them out and that's it till the next release date. What's the first thing in that idea that goes wrong?
Yeah, I think so. In an ideal world, that's exactly how it should be, right? Just like how you described it. You finish signing off, and then you ship it. You're done, and then you go off working on the next one, and you know that things will be handled magically behind the scenes. Except that's not quite how it works today, and that's where we want to get to with the stuff that we're building. So I think taking a step back into why is this so different and why is this interesting, we can start with what is so unique about Confluent Cloud. I think the unique thing about Confluent Cloud is the way we have structured, the entire landscape of our products and services. So we have what is called as the data plane, and then we have the control plane. The data plane is the one which basically is used to deploy all the Confluent products. So we have thousands of instances of Kafka clusters. We have, similarly ksqlDB clusters, Connect, Schema Registry, all of these deployed in hundreds and thousands of instances across all three cloud providers, across various regions, and we have our customers, our Confluent customers, directly interacting with them to egress ingress data. Now that is one part of it, and to in order to make all of this even possible, right? Like we use Kubernetes as our layer of abstraction, but then to even allow all of this to run in Confluent, we have what we call as some of the satellite services, which are again, deployed in thousands of Kubernetes clusters, where all of these Kafkas and all of these products are deployed. And so we are basically looking at a large scale of instances and applications that we run. And here you see that running this manually or running this through scripts is not a safe approach. It's not a sane approach anymore. You need uh, some sort of safety mechanism, some sort of protocols to be able to manage all of these in a better manner, right? Like having mature operations is very core to any technology company, and I think with fleet management as a platform, the systems that we are building are going to aid just that. And so basically, like the systems that we are building are going to provide better mechanisms to roll out things in an automated fashion across this fleet, and to be able to have safe deployments, to be able to know what is going wrong and proactively figure out what might happen, and allow the give a chance to the human operator to go and figure things out and fix things, so that the external customer is not being affected. So there is like always this focus on how our external customers are going to be able to continue running their operations using Confluent hosted instances, and how do we aid that and how do we make that happen.
So, if to summarize that, then maybe so you've got actually getting the job done at scale,
Mhm.
monitoring that you did the job,
Mhm.
and making sure you do the job transparently.
Right.
So maybe we should break those three down individually. So actually doing the job, I would there'd be some people thinking, is that not just a Kubernetes command once you've updated the configuration? Why is it harder than that?
Yeah, so I think the whole operation concept can be broken down into select, apply, and monitor, and then rinse and repeat, right? So basically, when you have thousands of instances and you're looking at 2x, 3x growth for Confluent customers, which means that we are possibly going to see a 10x growth in just the cloud footprint.
Mm.
To be able to target the right instances or right parts of the fleet becomes critical, right? We cannot just go and start to upgrade something that is belonging to the customer, and then the customer goes down, and that's not a situation we want to be in. So essentially, be able to select the right targets in the right order, and then apply that operation. Sorry.
Is this targeting certain kinds of service or targeting certain kinds of customer you're talking about?
It could be either. So,
Okay.
yeah, so the selection process is pretty involved. Today, some of it is done manually, but we want to automate all of that. But essentially, like in a futuristic world, we are basically wanting to have a way to basically describe that fleet and say, this is these clusters are good for Canary, right? These are some of our Confluent internal
Good,
clusters.
good for Canary?
Yeah. go canary them, roll out the initial.
Oh, these are customers we can shove down the mine to see if they.
Oh, no, no. So these will not be the external customers. These will be
Okay.
our internal. Oh, yes.
Right. Okay.
No external ones. Yeah. So be able to target some of our internal test clusters. Maybe sales
Right.
is
Okay.
using something, or we are using something internally, and then go and target maybe customers that are, who have their Kafka or other Confluent product clusters running in their non-prod environments.
Hmm.
So we are not really touching anything that is in their production. And then maybe there's a metrics based thing. Oh, if the CPU of this is running high, then maybe go target those first and fix those. That could be one kind of selection strategy. So you'll see, like, it's a huge combination of things where it could be cloud based, or it could be region based, it could be customer based, it could be metrics based. So in order to kind of describe all of this in a coherent manner, in a way that can be handled by a human operator,
Mm.
and like, not have them run around looking up databases and metrics and creating Excel sheets and manually
Yeah.
doing all of this. We obviously want to get away from that world, and basically provide that developer experience during rollouts of any software.
Sounds almost like you want to create like an SQL front end to figuring out which parts you want to update.
Yeah, sort of, kind of, but maybe we kind of also want to take it one step further and say, you describe it to me in the form of a JSON, or, like, use a gRPC endpoint. Just write out
Okay.
the strategy,
Yep.
and then we'll convert that into SQL queries or whatever is required, generate that plan for you, and then we'll go and execute it once you approve it.
Okay.
So which means it's like, if you have some predefined strategies for the developer, it's basically feed in the strategy, make sure the plan looks okay, and then give a thumbs up, and then off you go on your next project. And the system is going to handle everything else.
And that does actually start to seem analogous to a query with a query planner, right? It's the same idea transferred into a completely different world of running machines.
Mhm.
Interesting. So, and then once that selection process has happened, the operate process is Kubernetes. Is it other things as well?
Yeah, there are a couple of steps before we reach the Kubernetes side of it.
Okay.
So that's where the control plane comes into picture. And I think we have this way of describing, our clusters, as we call them, like the Kafka clusters, in the form of a spec. And we kind of need to build up that spec to include maybe the image version that we want to deploy, maybe the feature flags that have been turned on for a particular customer, maybe certain special configurations that are there. We kind of build up this spec, and then the control plane sends it down to the data plane. And we use Kafka in this whole thing. We use our own products, of course, and that's what makes all of this happen on a multi-cloud environment. And we push that down to the data plane, and essentially, the magic happens after that with the operator and the Kubernetes API.
Okay. And then, so it goes through. We had a couple of guests on telling us about the control data plane separation that happens, right? So you're figuring out what the new spec is that goes onto a topic that gets transferred down to a data plane that runs the actual Kubernetes job that resynchronizes everything.
Right. Yeah, and some of these are described as stateful sets. Some of these are deployment objects. We let the operator and Kubernetes API handle that bit of it. Yeah. So that's like the apply part of it.
And so that does that form part of your fleet management remit, or is that sort of cloud ops ish? Is that already there that you're building on, or is it your job?
Yeah. So I think basically it's already there. The core of it is already there. Of course, there are usually some enhancements and stuff that always have to happen. But that core of, one unit of operation needs to be defined, and we plug in the operation into fleet management, and then we can scale that out across the cloud.
Okay. Right. So you're building up the specific description of these particular types of batch job that get that perform the transformation. That's what we're saying.
Right. Yeah.
Yeah. Okay. And then we come into observing it all,
Yeah. So that's
which
another
is
the
often the
next.
biggest job, right?
Yeah. So that's like a very interesting piece, and that's one of the I would say the highlights of having fleet management platform, and using us to essentially drive all of these operations on the cloud. And that is like having active monitoring. We've, at least from what I've observed in the past, and even to some extent, even today, I think that a bunch of time goes away in people trying to make sure that things are fine. Of course, we have we use Datadog, so we have metrics, we have alerts, we have all of those things, but yet there is some amount of manual intervention that happens. Hey, is this rollout going on fine? Is something not looking all right here? We've automated some of this for a subset of the fleet, and we plan to extend that out further. But essentially, our platform is going to listen into the alerts and make sure that there is nothing bad happening on a particular target that we are operating on. um, but then if it detects that something bad is happening, we are able to make that decision to either pause it or error out the whole thing, so that we don't spread potential bad changes across the fleet, and we contain that within the blast radius. So
Okay. So if you automatically noticed that something was going wrong with one particular recipe, let's say it is, you would halt it from being applied to other future clusters that are kind of in the queue.
yeah, that's right.
Okay.
Yeah, so basically we are cutting out that entire turnaround time, where a person would be alarmed about certain problems, and they would have to log in and figure out what's happening, and then go figure out what is the operation to go pause it and then go and debug. So
Yeah.
we're cutting all of that out and saying the system can react. We just need to know what to listen for, and how to we want to know what to do to pause a certain operation, and that's it. Like we're within a few seconds, we should be halting that process until someone comes in and tells us, okay, you can proceed, or yeah, it's good, you stop. Don't proceed.
Okay. So give me a concrete example of that. How is it actually? Take me through a scenario where it actually finds a useful metric and how it processes it.
Yeah. So let's say that there is a fleet-wide upgrade going on for Kafka clusters. So today we have close to 2,000 clusters running, and let's say that we have a rollout for image version 1.x, right, going up. So someone has prepared all the clusters, and they've fed that in, and they've called a fleet management API to say, go apply this across the fleet and let me know once things are done. So fleet basically, the system basically is going to chunk up this entire list according to certain criteria. Once we have the deployment strategy based deployments, so we'll chunk that up. We'll do some amount of parallelization. We of course will not try to go one cluster at a time, because then it'll finish only after 6 months.
Yeah.
So we'll try to roll that out batch by batch. And then, since we have Datadog agents and metrics and all of those being produced from the Kafka brokers, they are getting streamed out into our metrics API. They are also getting into Datadog, where certain alerts may have been configured. Now, for each Confluent product, we have asked that each product owner defines what are the critical alerts. Right? They say, okay, maybe the CPU should not go too high, maybe the throughput should not suddenly drop to zero, maybe the latency shouldn't start to spike.
Yeah. Yeah.
So those are some of the simple ones, and there'll be a little bit more complex ones, especially around maybe storage sizes and all of those. So we have around on the order of around 10 alerts that are configured for during rollouts for each product type.
Hmm.
And once we have this, the fleet system basically constantly monitors and checks is are any of these alerts firing. And let's say it detects that maybe one of the clusters is showing a drop in throughput.
Yeah.
Maybe it's dropping requests. So then we kind of know that, okay, this should not have happened. So then we immediately send in a pause signal from fleet system into the control plane APIs on all the currently running upgrades. So maybe we have 25 in parallel. We go and pause all of them, and we also block any further new ones from getting picked up and getting processed.
Can you
So what?
pause them? Sorry, can you pause them cleanly?
Yeah, we should be able to pause it cleanly. Yes,
Yeah.
right
It
in
won't
the
be
middle of a broker. Yeah.
even if it seems like it's halfway through.
Yeah. So let's say a Kafka cluster is, 12 brokers large, and maybe the sixth broker was just getting bounced and it was just coming up, and we
Ah, okay.
started to detect it. We basically send a pause signal, and this seventh one will not be touched. It'll just halt. So
Right.
the
Okay.
operator
Yeah.
is geared up to, yeah.
So it doesn't try to roll back all six.
No, it will not roll back just yet.
Okay.
That'll
Okay.
probably be V2 version of Fleet.
Okay. Let's not get ahead of ourselves.
Yeah.
So it's pausing that apply queue at the same time, right? And then
Um,
presumably someone comes in to manually diagnose it before you continue.
Correct. Yeah. So we can go and pause it, and that'll basically send in a notification. So we've hooked up automated Slack notifications as well. So people kind of don't have to come and keep polling the APIs and is it done. They just get the notifications on their Slack while they are working, and they'll notice that, oh, something went wrong and it had to be paused, and then they know that none of the other clusters are affected. They know exactly where to look, and they can take their time and do it, right? And once it's fixed, then they can kind of hit resume and we can keep going.
Okay, and it can it resume? Can you like replace the unapplied ones with a new specification potentially?
Yeah. So resume basically continues rolling up the rest of the brokers. So the entire Kafka cluster is now at the right image, and the new Kafka clusters will continue to get the right version.
But if you discovered it was a problem with the particular software you're rolling out and you patched that software, can you then go and say everything that I was halfway through upgrading now needs to upgrade to this version instead?
Yeah. So that bit is a little bit of because when there is a fix that needs to go in, maybe it's a hot fix, we kind of need to patch that in. We'll then have to restart the whole workflow. So basically, that workflow is errored out. It has to be killed or aborted,
Right.
and then we rerun the workflow, and then the whole thing starts again.
Okay. Okay. Out of interest, what does the tool set look like for someone running this process?
I'm sorry, what was your
I
question?
mean, what does the tool set look like? I mean, if I'm the person trying to do this job, am I running command line APIs? Have you got a user interface for the back end management? What's it look like?
Yeah, so this kind of opens up some interesting things around the evolution of what we've built so far. So a few years ago, it was a handful of clusters. It was done manually, and then we went into tens of like around 100 clusters. We started using scripts, and then we started to look at 200, 300, 400 clusters, and then
Yeah.
we discovered, well, scripts are not going to work out, and it takes a lot of time for people to manually monitor things, because there was a time when I was essentially opening 20 tabs on my browser and monitoring them. And then we moved on, said, okay, let's build an automated way of doing this. And so now with a order of 1,000 clusters, we are able to do it through a CLI, and basically call the fleet management API. And where we have some of the APIs that are required to roll things out, check the progress, and all of that. But now, interestingly, what we're seeing is that doesn't scale either. Like even the CLI becomes a bit of a manual overhead because there is some extra learning that every new developer has to do. And we have a lot of, the engineering group is growing really, really fast. And for each person to now come in, learn the CLI, learn that, okay, you have to log in, now you have to check this, read run books, it consumes time. Everyone's
Yeah.
busy and we are trying to do a lot of different things. So, we cannot have just one part of the operation can take up a lot of time from each developer. So what we noticed, and after talking to different teams, we figured that having a UI might be a better way to do it. And so what we've done, and we basically just launched the new rollout service, the fleet-wide rollout service, and the Fleet UI um, in like a couple of weeks ago.
Oh.
So yeah, I think the team is everyone really came together, and we kind of shipped that over the last few months. So now we are basically looking at a UI based solution where a person can, go in and create their rollout plans. They can watch the progress. They'll get all the data that they are looking for without having to read any run book and run any CLI. It'll just be there on the UI page for them to go and take a look. So we are kind of making that much more easier for developers to go and operate their fleet-wide rollouts.
Oh, wow. So the whole back end developer experience for this has been a real evolutionary journey.
Yeah, I think from the backend perspective, first of all, our team has no UI expertise, so it's really amazing how everybody kind of ramped up on that and started to build all of that, and how grossly we had underestimated it initially on how much effort it takes.
Front end work is harder than it looks.
It is, yeah, it is. Lesson learned. Um, but I think from the backend perspective, we've kind of opened up. We've kind of gone, contract first, API driven backend,
Mm.
where and it's a Java based service. So we are kind of opening up the gRPC APIs for people to kind of plug in their rollout plans eventually, and use the whole active monitoring notification, all of that built in, and go fleet wide, run at scale, um, and kind of build out that system. And with additional features like let's say it's pause, like you should be able to resume a workflow without having to abort and rerun the whole thing all over again. And features like error budgeting, maybe one errored
Error
out.
budgeting.
Yeah, like maybe there is maybe there are one or two clusters that where there was a blip. We kind of go and pause the whole workflow, but maybe that was not required. Maybe it was just a one-off thing, and someone has looked at it and it seems fine. And we saw that this started happening quite a bit, where sometimes some of the alerts may be a little too sensitive, and so we want to kind of allow putting error budgets where we say tolerate a little bit of error, it's okay, right? And just keep going. And maybe 10 clusters are erroring out over across various phases. And then maybe it's a problem. And then we stop. So
Right.
essentially to make it a little bit more smoother.
So you're programmatically allowing for the fact that reality is never smooth.
Yeah.
Fair enough. That seems very sensible. Um, One thing, this is probably more getting right into the nuts and bolts, but is life made significantly harder by the fact that Confluent Cloud's rolling out over things like AWS and GCP? And you've got a lot of different APIs under your APIs that you're dealing with. Does that make life much different?
From the fleet management perspective, not that much. I think because some of the APIs that we've written and the operator that has been written, they are built in such a way that, and because of course Kubernetes that we use, I think they've been built in such a way that the higher levels of abstractions need not absolutely worry about cloud specific features and cloud specific APIs. They get handled at a lower level. So of course there is a little bit of special casing sometimes based on the cloud provider, but that kind of gets hidden away, and we've consciously made that separation of concerns. that we don't have to deal with oh, a particular cloud is such and such, and hence it has to be done this way. Not to say that eventually that will not happen. Like if a certain, if there is something special that needs to be done for a certain cloud at the fleet rollout level, then we will do that. But otherwise, we would expect that it gets handled in the core API itself.
Okay, so we really are dealing with a level of abstraction above something like Kubernetes, where we're saying, okay, you've got this wonderful rollout tool for a single spot,
Mhm.
but what are you rolling out when, and what are you not rolling out, and what happens if something goes wrong? And it's that
Yeah,
management of a vast number of different possible Kubernetes recipes that is really where you come into.
right.
Yeah, okay. I think I'm clear on what fleet management means now.
That's great.
So there's one big thing that we touched on at the start that we haven't really talked about, which is how do you do all this while without the customer noticing
Mhm.
as far as possible?
Yeah. I think it's a combination of different things. One part is kind of knowing what the fleet is looking like, right? We want to have visibility on everything that's running across the fleet. So basically, we are looking at building out. We are currently kicking off building out the View API, which is a beast in itself. I could probably talk for another 2 hours about it. But in a nutshell, it's about getting like a full fleet, like a wide angle view of the fleet, knowing what the control plane sees, knowing what is actually happening on the data plane, being able to go back in history and understanding, how certain rollouts have gone in the past on specific targets. So maybe there is a
Okay.
particular cluster of a particular customer whose cluster is having constant problems, right? We should be able to go back in history, go back 6 months, and see how many times during rollout this particular cluster kept alerting. And then, you can derive a lot of new insights on specific customers. Today, a bunch of this is a little bit of tribal knowledge, and I think having this historical view of things will kind of capture all of that knowledge into the system itself. So we kind of can then make things better for those specific customers, and kind of make some adjustments and see how to kind of not have these kind of problems keep popping up for them. So visibility is one aspect of it, right? The other aspect is the active monitoring that we spoke about, where uh, like before things go too bad, we will notice it and we will do the right make take the right steps. So that basically helps in not having complete downtime for a customer, and maybe they are degraded for a little bit, but then other customers are not getting affected either, because now it is contained to just a very very small subset
Yeah.
during that rollout.
So
And
you
I
might
think,
you might be in the situation where because you've caught it quickly, 2 out of their 10 brokers went down, and so they are affected, but not nearly to where they'd be had it been a manual process to step into.
yeah,
Yeah.
because the time to react is that much faster by the system,
Mhm.
whereas manually, missteps can happen. People make mistakes, like it happens all the time.
Yeah.
So we kind of cut out all of that. And I think the Kafka system itself and the way the operator and all of these are written, we kind of we have certain checks at some of the low levels as well, to make sure that not everything goes down. Like it at max it gets degraded, but it doesn't really go down as such.
Yeah. Okay. Um, yeah, I can see that. So there's one other question I want to ask you about that, which is how much is it how much is it relying on the fault tolerance of Kafka itself? Is that a big part of how much transparency you can provide?
Yeah, so I think fault tolerance within Kafka definitely helps a lot. It helps at the basic cluster level for a specific customer, right?
Yeah.
So basically, you can kind of, like we said, it might be degraded, but it won't completely blow up. But I think getting those metrics and getting all of that out of different Kafka clusters and learning from it and making sure that it the other customers are not getting affected, who have not yet started to get upgraded. I think that is one of the key values that we bring, to be able to apply that and kind of make sure that we are not destroying others in this process.
Yeah. Because I guess with this kind of scale, you can step into one customer and manually massage things to make sure they're up quickly. But
Yeah,
if you've taken down 50 or 100, there's no possible way you can react to that.
yeah, exactly.
Yeah, yeah. Gosh, it makes you. These problems only come up at this kind of scale that you have to start automating for.
Yeah,
It's quite an astonishing. I get the feeling you get a kick out of doing that kind of work.
yes. Yeah, it's been super exciting. I think some of the things that we are trying to build, I think they are there in terms of concepts in some of the larger, cloud companies. Like it's there in Google, we know it's there in AWS. I think it's also there to some extent in Facebook and Uber, but not much has been spoken about it. Not There's not much information as such about it, and it doesn't kind of come together as, hey, in order to run at this kind of scale in such a heterogeneous environment, you kind of need to have all of these blocks in place, right? And I think that's what we are trying to do, like bring all of these things together. How do you do rollouts? What should the experience be? Because engineers are important too. Like we don't want to have crappy experiences. We want
Yeah,
to be able to do all of these operations and then go off and work on other important things. Having visibility at various levels, and the amount of data that we can get, and amount we can learn to kind of make this better in the future. Having safety, right? Like safety is one of it's part of our mission itself, and a lot of this that we are talking about is to bring that safety to our external customers while we are performing cloud operations on them. So I think, be able to, first of all, limit blast radius and all of that is one part of it. But eventually, we are kind of also looking at being able to apply maintenance blocks, like, cordon off a part of the fleet, maybe describe it as a policy, where, no matter what happens, not that part is fully protected, and there is no fop power there. And like, we kind of, we are upgrading everything else in the fleet, and this particular part is completely safe. Maybe it's a Thanksgiving weekend, and certain customers don't want to be disturbed during this time.
yeah.
um, yeah, and like to
Maybe
be
you
able to
block out all your florists the day before Valentine's Day, right?
yeah, exactly.
Yeah,
And like make sure that our customer is successful,
yeah,
which means Confluent becomes successful, right? So once we have all of this in place, that's kind of that makes it a more well-rounded system or a well-rounded platform, and
mm,
then we can use it in different ways. Having describe things with policies, make it as flexible as possible, allow overrides wherever it is necessary, and these are literally some of the projects that we've I think it's been around 2 years since I've been like, forming all of these ideas. And I'm so excited that over the past 1 year, like we formed this team, the fleet management platform team. And, all the engineers there, like everyone's coming together, working on all of these designs, building out all of these systems, productionizing them, and kind of killing off one after the other and kind of making this a complete platform. So in fact, this year is like the year where we worked on rollouts, which is continuing. We are kicking off visibility, which is going to take off, and we'll be taking off on safety as well to do the maintenance windows a bit of it.
okay. Plus, you're presumably hiring a front end engineer. You're writing a book because no one else has written this yet. Um,
I think we'll see some blog posts coming out of us very soon.
okay, that'd be a good start. Let's not write the book this week. So, where do you think you'll be on this in a couple of years? It's always hard to estimate, but give me a guess.
Yeah, I would say in a couple of years, we'll have, perfectly automated rollout system. and we'll have complete visibility. I think this is definitely a reality. Like we will have deployment strategy based rollouts because we are already working on it.
Hmm.
We will have complete visibility across the fleet now, and like work on how this data can be consumed, how it can be ingested,
Mm.
and also have better described safety rules and safety mechanisms, so that all of these operations become seamless and very well automated. And eventually also kind of have the system now tell you, hey, I detect some drift here. These certain clusters are running way behind. Looks like the fleet upgrades never reached these for whatever reason. Maybe they were
Okay. Yeah.
aborted,
Yeah.
maybe they were killed. Being able to roll out security patches very efficiently, right? Like you might have fleet running in two modes, where one is an emergency mode, maybe there's a security vulnerability. We want to roll things out to all the ksqlDB clusters, right? How
Yeah.
do we do it in like the smoothest way possible? Like risk versus pace is always a balance. I think in regular operations, it would be make sure that it's not too risky, but also not too slow. But maybe in in security patches, you want to be really quick, because you do have some people monitoring it, so then you can kind of make some workarounds. So I think there are multiple modes in which fleet can run and fleet should support going forward. So yeah, these are all some of the open questions that we are looking at, and seeing how to address them.
Cool. Presumably, some of those will feed into each other, right? Like when you've got visibility of 3 years worth of customer data, you can start writing new safety heuristics rules
Yeah, yeah,
based on
absolutely.
yeah. It's an interesting future.
Mhm.
So this, if there's one thing I should take away from learning more about this world, what do you think the headline is?
Can I give you four?
Yeah, four. Okay, okay, I'll let you have four. I'm
um,
counting though.
okay. Yeah, I think one thing is making sure that, like, we do whatever it takes to protect our external customers. I think that's the main core focus that needs to be there.
Yeah,
Um, because we don't want to have a provide that crappy experience where a customer finally feels, I could have managed this myself, right? Why am I paying Confluent? Like, we don't want to
yeah,
get
yeah.
into that at all. So making things as seamless as possible, as safe as possible, and keeping them notified, right? Like notifications is important to a good extent, because they want to know what just happened.
So do you
Maybe
think?
there's a problem.
Sorry, not to interrupt your list of four, but do you think this View API that you're building will eventually feed back into something customer facing?
Potentially. I think the safety part of that would actually be a little bit more customer facing thing, I would
Hmm.
say, because then eventually we could get into, like, once we have all of this built up, we could potentially have customers, say, define those safety rules for us, right? They might put in a policy saying, do not do this for me. And then it kind of gets delegated to our customers to tell us how they want to be managed. And
Mm.
that's I would say it's a good way to be in.
Okay.
Yeah, and the visibility part, I think for a particular customer, showing some of their historical data might make sense. But since we run a lot of multi-tenant setups and all of that, maybe they may not be as interested in everything else that's happening across the fleet. But yes, for that customer, maybe there'll be value in bringing up some of that data and showing it to them.
Yeah. How often you've been updated without realizing it might be an interesting statistic.
Yeah,
Yeah. Okay. So that's is that one or two that we've done? Safety and visibility.
yeah, I
One
think
and a
that's
half.
true.
Okay. That's two.
Yeah, safety and visibility, definitely. And the other is, I think, developer tools. It kind of, we are trying to give a new meaning to it. Like, it shouldn't just be limited to some quick scripts or just some CLIs. I think it's important to kind of build a good product even for developers, because this is what developers do day in and day out. Maintaining production, operations on production, and it needs to be intuitive, it needs to be easy to use, and it needs to be safe for them, where
Mm.
they don't have to worry about, oh, I just issued a fleet-wide upgrade and I'm not going to sleep the next 5 nights until this finishes. Right? It shouldn't be that way for them. It should be more like, I'm confident of what I'm doing because I know the system is there to support me, and I can rest.
Yeah.
Yeah.
I'm going to risk sounding a bit like an advert here, but I'll do it anyway. One of the things I quite like about working for Confluent is we're building things for developers, and it's a very different kind of business when you're building stuff for developers, right?
Yeah.
It's like you're talking to your own people in a way
Yeah.
as a
Yeah.
developer, but you're another layer on top of that. You're developers building for developers who build for developers.
Yeah. A bit
So
of
it's the very
inception.
purest form.
Yeah. Yeah. I think currently all of engineering is our direct customer, I would say, right? Like,
Mm.
so we're basically working with our developers. We get feedback from them right then and there, and we know how to kind of, what to work on next and what should be the priority. And I think we've learned a lot, speaking to other teams, speaking to other engineering teams, and it has helped shape the product quite a bit. And like, our roadmap and everything. So yeah, I'm really thankful for that.
Oh, cool. Are you hiring at the moment?
I want to say I'm always hiring.
Okay, fair enough.
We definitely need, developers, engineers coming in with this kind of mindset, like, be customer focused, be developer focused, and build the right systems.
Cool. Maybe we should put a link to the your specific job board in the show notes.
Yeah.
Rashmi, this has been really interesting. It's a bigger world than I expected.
Mhm.
So thank you for teaching me about problems I don't actually want to manage myself, but I'm very, very glad you're thinking about.
Yeah. Yeah. It was nice talking with you too, Chris. Thank you.
Thanks for joining us. Bye.
Thanks. Bye.
And there we leave Rashmi, who I think has a fair claim to the title of the developer's developer. She's definitely hiring, so if you're as enthusiastic as she is about these kinds of problems at this kind of scale, check for a link in the show notes and we'll link you to the job board. I will remind you before we go that if you want to learn more about Kafka, we've got documentation, tutorials, courses, and more over at developer.confluent.io. And when you want to apply what you've learned, you can easily get a Kafka instance running at confluent.cloud. Sign up with the code podcast100 and we'll give you $100 of extra free credit. In the meantime, if you've got questions or comments or just warm fuzzy feelings about this week's episode, you know what to do. Click the thumbs up, type in the comment box, leave us a review, drop me a message on Twitter. All the links are in the show notes. It's not just Rashmi that needs to monitor the health of her services. Streaming audio does too, so get in touch. And with that, it remains for me to thank Rashmi Prabhu for joining us and you for listening. I've been your host, Chris Jenkins, and I will catch you next time.